Hey math kids, today we're going to talk about quantiles, and really all that is we're going to be talking about everything we did on the previous video but in reverse. So in this particular problem, we have a normal curve, the mean is centered at 70, and we have a standard deviation of 10, and we want to find some x value that they're calling k that creates 95% of the area is to the left of that value. So in other words, the area under the curve to the left of that value k will give us 95% of the area, or 95% of the probability, or however you want to think about it. So to do this, we have to use our calculator, and we have to do an inverse norm function. Now with inverse norm, it assumes that we're doing less than. So for this problem, it's just going to work pretty normal. But if we ever had a greater than, then we would find the answer, and then we'd take 1 and minus that answer. Okay? Alright, but on this one, it's less than, so it assumes less than, so we're fine. So we go here, we go second, catalog, click the I, go down till we see inverse norm, right there. Okay, the first argument is the percentage, so we want to find 95%, and then we just type in the mean and the standard deviation. So since this is normally, oh whoops, that's not right, what am I doing? The mean is 70, and the standard deviation is 10. We hit enter on that, and we get 86.5. No, 86.4. Okay, so that k value right here is 86.4. Okay, and we're going to move on to the next one. So it says the weights of an adult scallop population are known to be normally distributed with a standard deviation of 5.9 grams if 15% weigh less than 58.2. Let's see, 58.2 grams. So we're less than 58.2. Find the mean weight of the population. So we want to know the mean. Alright, so what we're going to do, we're going to take what we learned in the previous video, and let's see, so we're given that we have a normal distribution, we don't know the mean, but we do know that our standard deviation looks like that. And then we know our probability is when x is less than 58.2, and we know that that is 15%. Okay. Now, because we don't know the mean, we have to change this to a z-score. So we're going to say z is less than or equal to, once again, we're using that z transformation, which is x minus mu over sigma. And so we're going to plug in our x value. We're going to subtract our mu, which we don't know, and then divide it by our sigma, which is 5.9. Now, we know all of this is 15%, and we know that this is a z-score now. So what we can do is we can go to our calculator. We can do an inverse normal. We can type in our percentage. And now, because it's a z-score, our mean is 0 and our standard deviation is 1. Hit enter on that, and we end up with negative 1.04. And so we get Okay? And then from here, we can just do some basic algebra. So we're going to multiply both sides by 5.9. Cancel right there. And then we're left with 58.2 minus mu equals 5.9 times our previous answer. So we get negative 6.11. Okay. Then we want to subtract 58.2. Let's cancel. So I'm subtracting 58.2 from my previous answer. I get negative 64.3. And since they're both negative, my mu is positive 64.3. Okay? Now we're going to do the last one. Find the mean and standard deviation of a normally distributed random variable x for which the probability of x being less than or equal to 20 is equal to 0.1, and the probability of x being greater than or equal to 29 is equal to 0.15. Okay, so our distribution is going to look like this. We don't know really anything about it. So we're just going to leave it like that. Okay. So we need to find z1 and z2. So if we just call x1 20 and x2 29, the two x values we're interested in. So if we look at this is x1. If we look at this is x2. And we have some mean that's in the middle. Okay. So we're going to set it up. We're going to say p is less than or equal to x1. That's equal to 0.1. And if we change that to a z value, we're going to get z is less than or equal to 20, which is the x value, minus mu over sigma, and that's still equal to 0.1. And then over here, we have a similar situation. Actually, I don't want to do it that way. We're going to say that's equal to 0.85 because, once again, we want to find the value, we have to say everything that's below it. So when we're right here and we have this value, 0.1 is the value below it. But if right here is 0.15, that's above it. And so we would have 0.85 if we were to cover all of this area. Okay, so as we're doing that, we set up another z, and we use 29 this time. Okay, cool. Now, when we plug this, we need to go to our calculator. We need to go to inverse normal again. Plug in the percent, 0.1, and then do 0 and 1 because it's a z. So we get negative 1.28. Okay, so 20 minus mu over sigma is equal to this, and this is like for z1 value. And if we go back to the calculator, go through that process again, catalog, I, find inverse norm, and we do 0.85, comma 0, comma 1, because it's a z. Hit that, and it's 1.04. Okay, now what we're going to do, we're going to go down here. We're going to use both of these to figure out what mu and so I'm going to take just this piece and this piece. I'm going to break up that fraction, so I'm going to bring my sigmas up. So I'm just multiplying both sides by sigma. So we get 20 minus mu equals negative 1.28 sigma, and then similar, we end up with this. Okay, from this point, we want to solve for mu, solve for sigma, and so what we could do is we could just use elimination. We could put them under each other. And if we just change all the signs on one of them, the mu's will cancel. So we add these, we get 9. We add these, what do we get? 1.04 plus 1.28, 2.32. .32 sigma. Divide both sides by 2.32. So 9 divided by our previous answer. We get 3.88. Okay, so that's our standard deviation. Now we can take that, we can plug it into here. So we're going to get 20 minus mu is equal to negative 1.28 times by 3.88. So we go back to our calculator, take that previous answer, times it by negative 1.28. We get negative 4.97. That's 20 minus mu is equal to that. Subtract 20 from both sides. That's going to be negative 24.97 equals negative mu. And so we just switch those signs. And if we round that to 3 significant figures, that goes to 25.0. Okay, if you need additional help, please come to Math Lab. Until then, calculator.